to the first session of the second day of UNIDO's second Bridge Cities event. Today we will address a number of solutions over the day, and I'm happy to start with the general topic of environment. What we will do here, actually, in this particular side event is of the Urban Industrial Solutions and Business Opportunities session, is we will look actually at the overarching topic of waste and how to do something useful for it, making it from a liability to a resource. And in order to do so, we looked at opportunities and challenges that you might have and experiences you have in industrialized countries and in developing countries with making this happen. And among other benefits, this would also typically or frequently lead to a separation of different types of waste, which then can also be, other components can be recycled instead of incinerated. And all of these things are items that we in the Department of Environment are working on here in UNIDO. But without further ado, I would very briefly lay out to you how this first session will be organized. We will first have a keynote address of Mr. Peter Pluschke, who is the Deputy Mayor of Nuremberg and responsible there, among other issues, for environmental questions. And he will inform us about some of the relevant experiences with waste and incineration in the city of Nuremberg. And then, after that keynote address, we will have a panel of 3 members, which I will subsequently introduce to you. And after some brief statements, we will enter into a discussion to which I would like to invite all of you to participate. If you want, just raise your hand, and I will take note and ask you to take the floor. And then we will aim to learn for all of us the maximum out of this session. I hope it will be interesting. And I would like to ask now Mr. Peter Pluschke to take the floor. You can do it from here, you can go there as you wish. That's what you say.
Okay. Good morning, everybody. Thank you for inviting us to give a short report on our ideas and our realities in waste management. I'm not talking about a full-fledged system which might be applicable anywhere in the world. I will share with you some reflections on the state of waste management and on the perspectives, and will highlight a few experiences from Nuremberg. Now, how to move on? Yeah. Here it is. A few words about the city. According to Chinese standards, it's a small city. According to German standards, we are ranking 12th in number of inhabitants. It's a big city in Germany. What might be interesting for you is that we won the National German Sustainability Award in 2016. So we are proud of at least of our efforts to improve the sustainability and the resilience of our city. This is one of the marks we show to the world. We understand, and this is important also for waste management, we understand that a city of our size alone will not go into the future. We are sharing our experiences, and we try to develop our structures on a regional level. The metropolitan region of Nuremberg covers the biggest part of northern Bavaria, and we are 3.5 million inhabitants in this metropolitan region. So what many things we do in mobility and transport, in waste management, and in other affairs are now going more and more on the regional level, which strengthens structures. To talk a bit about the present situation in waste management. Well, we're coming from the term waste management because 20, 30 years ago, waste piled up and it had to be treated, we had to get rid of, and this was the first phase to install units for landfilling, for incineration, etc. But meanwhile, and the European authorities are working on that very hard, we are trying to move over into more circular economical structures, which means that materials we use have to go through cycles of use, have to go through more loops. And we're discussing ideas like the Zero Waste Society, which is a strategy and a set of practical tools which is seeking to eliminate waste, no more to manage it. It's a large-scale goal, I would say. Another wording you will hear very often is cradle to cradle, which means that we are remaking the way we make things to do it in a way that we are able, by very simple means, to reuse them. This is more or less the political setup which gives us our perspectives, and perhaps I can show you the waste hierarchy, which is all over the world well known. Meanwhile, we try, first of all, to prevent waste, to support activities and structures which lead to reduced mass of waste. Secondly, we try to recover whatever is to be recovered. This may be energy, heat we recover from waste, but more important, we try to recycle materials and to develop structures which allow to recycle a maximum of materials and preferably on a regional level, which means we also try to reduce logistic efforts and emissions resulting from logistics. Final disposal, which is now marked at the very low end of the hierarchy, plays no more important role, at least in Germany, but I know in many places of the world, landfilling is still very important and must be done in a proper way to save our environment. Talking about our way to handle waste, the German system is a mixed system with a public role in waste management and an important role of the private sector, which has been defined by law. For example, most recycling activities are done by the private sector, whereas, and this is the case in my city, we are dealing with most of the household waste. I'll show you what kind of installations we are running. We're doing it, we have a public company, which is ASN, Abfallwirtschaftsbetrieb Stadt Nürnberg. This is running our installations. It's a city-owned subsidiary company. We established it in '99. We have no private shareholders, and it's not included in the budget of the city. It's a company which is running on the fees the citizens have to pay for dealing with the waste. And we do that in a regional cooperation, which means that we're not only serving the city of Nuremberg, but also a number of cities in the environs. To go briefly through the pillars of our concept, you know, Germany is trying to do as much reduction at the source and as much specific collection at the source. And so we are offering a number of facilities to do that. We have civic amenities sites, which are there to collect separately quite a number of materials. We have specific sites for garden waste collection. We have, of course, a separation system for glass container system, and quite a large number of more systems running. We have a number of recycling units, mostly run by private companies, and they are building an agglomeration of different units, which is very favorable, because then you can, after separating the various materials, you can easily exchange them between the companies active there. To show you the most important plants we are running, it's the waste incineration plant. This is under ASN, about 240,000 tons per year. We're still running a landfill site, which is under closure. It will be closed in 2022, finally, and we will not deposit any more waste. At the moment, there's only very small amounts of asbestos-containing waste deposited there. We have the civic amenities sites to separate materials, and we're doing a collection from households of hazardous waste from households, very small amounts. The commercial and the industrial sector has its own facilities for that. The picture you see in the German households is like that. You see the bins, different bins for paper, for packaging material, for organic waste, and for the residual waste. And we offer a number of brain systems for glass, for textiles, for garden waste, for other recycling materials. To give you the numbers, which are more or less the present numbers, to show you which ways the materials go. This is the setup of a system which has been developed over the last, I would say, 30 years. Very often people ask us, would you do it if you go to another place in the world? I would say no. If you start from a different starting point, then you can do many things today in different technological setups. And what is my experience? To start with a separating collection system, it would be most important to start with separating the wet organic waste from the dry material and elaborate on that basis. It depends largely on the local situation, on the type of waste you are collecting, what kind of technical expertise and what kind of technical face you need for the whole system. I think I may close at this moment. My time is over, and it might be a good starting point for a further debate. Thank you so much.
Thank you very much, Mr. Pluschke. Let me just make myself slightly more visible. Thank you very much, Mr. Pluschke, for your introductory words, which showed us how waste actually moves into the direction of waste incineration. And I would say, at least in the global context, this is kind of benchmarking where you can get in organizational terms. Without further ado, I would like to go to the next broad step, to our three panelists, which will all do some introductory remarks. And we are starting with Mrs. Franziska Hovorka-Sami, which is working since 2012 for the Department of External Relations in Vienna, famous Magistratsabteilung 48, the administrative office number 48, waste management. Here in the city of Vienna, her fields of expertise are related to waste prevention and external affairs concerning reuse, waste prevention and circular economy, and European affairs. Franziska, the floor is yours.
Good morning, ladies and gentlemen. thank you very much for the introduction and for inviting me to speak here at this event. The organizers gave me the strict requirement of only being able to use one slide. And it is quite challenging to speak about the Viennese waste management system with only one slide, but I came up with this chart, which shows the development in the last years. So let's start in 1945. World War II just ended, the economy started to grow, and so did the amount of waste. And since then, the city itself is in charge of the whole municipal waste chain. That means that the municipality is in charge of collection, treatment, and disposal of this waste stream. And that gives us the possibility to have this waste stream under control, and no waste leaves the system untreated. In 1963, the first waste-to-energy plant was built. Why? Because the main hospital needed to be heated. Some years later, a second one burned down. This is why you see that this black graph line hits a low here. And it was rebuilt in a very modern design, designed by a very famous Austrian artist. And the plant Spitalau today belongs to one of the Viennese landmarks. So today we have 4 waste-to-energy plants in the city with a total heat production of 1,200 gigawatt hours and electricity production of 81 megawatt hours. And of course, not only the main hospitals are being heated, but also 120,000 households are heated by means of district heating with waste. So what happened here in the 90s? The economy kept growing, the amount of waste kept growing and growing, the landfills were getting overfilled, the waste-to-energy plants kept operating at the limits, so something new had to be done. And this is why the separate collection system was introduced in Vienna, also driven by a law which was implemented in 1993. So today, 1/3 of the 1 million tons municipal waste arising in Vienna is being collected separately and recycled. And this had to undergo a very intensive education program of the public, because without the participation of the Viennese people, something like this is not possible. And you may wonder what this little picture is doing here. This is a collection box for goods for reuse. We do not only collect waste, but we also collect goods for reuse in order to prevent them from becoming waste. As we have just heard, that waste prevention is on the top of the waste hierarchy according to the European and to the Austrian laws. So this has been a very quick overview of the Viennese waste management system, and we are proud to say that this is a best practice example with an international reputation. But let me mention the key points again. So the responsibility for the entire chain of municipal waste lies in the hand of the city. Waste prevention as the top priority in waste management. Separate collection for recyclables. Thermal treatment for non-recyclable residual waste. As you see here, all residual waste is going to thermal treatment, and that makes it possible that no waste is going to landfill untreated. So I could go on and on, but I think my time is almost finished. So thank you very much for listening, and I'm happy to answer your questions.
Thank you very much, Franziska. Now I would like to ask Mr. David Tobin. David is a sustainability manager at the private sector company Lagan Cement in Ireland. He has worked in environmental management roles in heavy industry since 1996, with experience in a number of different sectors, and is considered a pioneer in driving the sourcing, planning, licensing, development, and use of alternative waste-derived fuels in the cement industry of Ireland. He also chairs Alternative Fuels subgroup of the Cement Manufacturers Association, same country, and is a regular contributor to the Environmental Science Association. So, David, floor is yours.
Thank you very much. Ladies and gentlemen, distinguished guests, it's a privilege to be here. I am an environmental scientist. I've been working for the Lagan Cement Group for 11 years. Everyone is familiar with bad stories about waste. Everyone is familiar with the stories of plastic waste at the bottom of the oceans, plastic waste being washed on beaches, and I'm here to tell you a good news story. I'm here to tell you how in Ireland in 2000 we had extremely poor recycling rates. I think we were only about 2 or 3%, and we were about 97, 98% reliant on landfill. And the landfills were all very badly managed. They weren't engineered landfills, and they were causing leachate pollution to groundwater and pollution to rivers, streams, and in some cases even leaking out onto beaches. So it was a terrible situation, and that's only 17 years ago. So Ireland, with a population of 4.5 million people approximately, with a pretty poor environmental record in 2000 as regards waste management. So if you fast forward to today, in 2017, we're the second highest ranked country in Europe for recycling. We are now much more environmentally responsible, and we have improved dramatically. Landfills are reduced from approximately 100 nationally down to only 4 functioning landfills, and this time next year there will only be 2. So it's been quite a big change. So how did it happen? Well, the first thing, and again, like Francesca, I have only one slide. So what I wanted to put up was an image of waste and how people have to rethink their attitude to waste. It's not a waste, it's a resource. If you look at people used to put all of their waste in the bin. Now we have a situation where if you look at the slide, it's raw materials. It contains aluminium, steel, copper, stone, glass. It also contains compost, soil improvers. And then for my industry, the cement industry, it contains fuel, contains SRF. So a very brief just description of the cement industry. Cement, as you know, is the glue in concrete. Concrete is the second most used commodity in the world after water. And that's a pretty staggering idea. I was speaking to my Chinese colleagues, and they were telling me about how much concrete is used in China, which is a staggering number. So to make cement, you have to heat limestone to 1450 degrees. So in Lagan's context, it was heating 1 million tons of limestone a year to 1450 degrees centigrade. And to do that, it was using 80,000 tons of coal. Ireland, as you know, on the western edge of Europe, doesn't have coal. So we were, as a company, we were extracting coal from South Africa, Colombia, Poland, and moving it across the world into Ireland. So at the same time, Ireland was hiding waste, which is a resource, into holes in the ground, badly managed holes in the ground around Ireland, which were leaking out and causing pollution. Lagan Cement was importing 80,000 tons of fossil fuel. So what we have done is we've taken the waste, we're getting it now processed to make a very high quality cement fuel, and we have successfully managed to displace 65% of our fossil fuel usage. So that's a phenomenal improvement. And SRF is primarily composed of material that can't be recycled. It's paper, plastic, plastic films, Mars bar wrappers. Everyone that had breakfast this morning, you probably had your jam pot, that sort of material. That's ideal cement fuel. it isn't conflicting with recycling. In fact, it allows more recyclable material to be collected, and what is rejected from recycling bins ends up as a cement fuel. So the other benefits of not just environmental with SRF use is that we also have a situation now where we have become more energy secure. We're importing less fossil fuels. We have local businesses that have gone about with great skill investing in local workforces. So we now have an industry making SRF. We reckon there's about 300 people employed nationally in Ireland in that waste sector. So really, it is a good news story. Ireland has reduced its dependence on landfill. Lagan has reduced its fossil fuel imports. We've also reduced our CO2 emissions, and we've created a local enterprise and industry around recovering the materials that you see in the slide above. If anyone has any questions, more than happy to talk about the details and Lagan's experience in this regard. So, thank you again.
And last but definitely not least, I would like to introduce Mr. Cheng Peng. He's working as a project manager at the Foreign Economic Cooperation Office at the Ministry of Environmental Protection in China. He has 16 years of research experience in the area of POPs reduction and prevention, environmental sound management of POPs waste, and cement kiln co-processing, which is here the interesting topic today, of hazardous waste. So please, Mr. Peng, we are looking forward to your remarks.
Mr. Chairman, it's my great honor to share the very interesting story, what happened with dealing with the waste by the cement industries. As you know that China have the largest cement industries. It has been for a long time. And according to the projection, China will still going these trends, stay in the first place. But as you see this chart, we also face another very serious problem, that is the overcapacity. So that means that lots of plants will take measures to survive in this competition. The other problems is that with the very quick urbanization, with the increasing the urban population, this municipal waste is will continually increasing. You see that just by the year of the 2015, the total quantity of the municipal solid waste reaching 108 million. I think that is a huge headache. And currently, the major disposal process is landfill, but soon it will replaced by the incineration. But another problem that is we couldn't follow up with the speed of the increasing of the waste. And you see that lots of the city using the incineration as the technical disposal technology to treat them. But the problem that is we couldn't find places to find them. And to build up the incineration plants, usually will meet with the NIMBY effects. We faced a very high pressure by public to reject to build the incineration plants. And also with increasing the population, we also faced with other problems, such as the fly ash generated by incineration process, and also the sewage sludge. So that's a problem. How do we dealing with these problems? One side is the cement industry want to make way to survive. The other is want to settle the problem of lack of the disposal facility. So co-processing is quite a good idea. It was entering the booming period just within the latest the 6 or 10 years within this period. You see that currently nearly 10% of the cement plants of China do the business of the waste co-processing. Now each year, that was data, each year we disposal waste by cement industries close to the 7 million. And I think that is a good way to dealing with the municipal solid waste, sewage sludge, and contaminated soil, and fly ash, and also the industrial hazardous wastes. You see that within the last years of the practice by this way, we also carry out a very systematic evaluation for the feasibility and economic feasibility and the technical feasibility. It is confirmed. That is sustainability and with multiple benefits just mentioned by Mr. David. And so that's, we can foreseeable the booming, the promotion of this practice will continue to be promoted. But as you know that waste co-processing in cement industry is not new things, which was already carried out by the developed countries for almost 40 years. We are just a newcomer, and we still have lots of the technical gap or managing issues, problems we need to settle with. We still have a long way to go. Thank you. I would like to answer any questions about this issue.
Thank you very much, Mr. Pang, for your interesting presentation. Actually, thank you very much to all of the panelists and the keynote speaker for their contribution. I think one of the commonalities clearly is that in all cases presented, we see waste being used as an energy source, either for thermal energy alone, or I think you were the only one mentioning also electricity generation in the plant. But of course it goes further than, as mentioned for the examples with the cement kilns. And first I would like to see if there are already questions from the floor, which there is. Yes, please. Floor is yours.
Hello. Thank you for the presentation.
Could you please briefly state your name and affiliation?
Yes, my name is Roxana Predoiu. I'm working for Capstraficom, but I'm currently doing some studies with the Technische Universität Wien. I have a question, one question for each of the panelists. So I will start with Mr. Pluschke, if that's okay. I know that Bavaria, the federal state of Nuremberg, has currently about between 30 and 35% of the photovoltaic systems installed in Germany. It's a lot of photovoltaic power installed in Bavaria, which will come to maturity, end of life phase, at around 2030. And e-waste, electronic waste, to which also the photovoltaic systems are part of currently, will be a big problem. It's a big problem in the world and be a problem also. How is the city of Nuremberg, what are the plans of city of Nuremberg in regards to processing the e-waste, which will the waste which will result from photovoltaic panels? And how will the city of Nuremberg ensure that environmental sustainability will be also accomplished? Not only economic value will be extracted from any recycling or treatment processes, but also environmental KPIs will be fulfilled. Thank you.
I think I have to give two answers. The one is what we're doing now at the moment. We don't have as yet a reasonable number of PV plants to be treated. We are the owner of the oldest ones in the city of Nuremberg, which are older than 30 years, they are still running perfectly, and there's no need to rebuild them. But we're already preparing for a broader collection of electrical material. We have, it's not PV, but the general electric materials. We have introduced a red bin, which is a collection bin specifically for electronical and electric equipments from the households. And we have added a collection system, a mobile collection system, specifically oriented to get the electrical and electronical material in a certain treatment row. I think the very same must happen with the PV, but there's obviously the producers are responsible to take it back and to do something about it. I'm sure because the material is very important for future that they will be able to recover a good part, but we trust that the private sector who is interested to get this material back will develop the relevant installations. I wonder if the time when we will have very large quantities of PV units is already very near. I suppose that they will be running a longer time than was expected, and it might be mid-20s that we are facing this problem. There's still some time to develop the structures for that. But there's a very important responsibility of the producers, the German and the Chinese producers.
Thank you very much. And before you have indicated you have 3 more questions, right? Before giving the floor back to you, I would just like to suggest that you might wish to target your questions ideally around the topic of energy from waste more than waste in general. I mean, I would really love to talk about e-waste, which is one of the issues that our department is working with. But maybe for the focus today, that would things take too broad. Thank you.
So my question for Ms. Franziska Hovor-Kasami is about the Spitalau thermal incinerator. Why is it that in the city of Vienna there are special bins for collecting bio waste, but this waste goes to the incinerator and there is no composting? There is no value extracted other than thermal value and is not used for composting. Thank you.
That's not true. We do have a very big compost plant which produces around 50,000 tons of compost each year. So we do collect organic waste separately and we do make compost out of it. What is in the residual waste bin, this is what goes to the incinerator, but nothing else.
Okay.
Can I just give anyone else, I would love to give you the floor 4 times in a row, but before doing so, I just want to look around if anyone else wants to take it in between. Good. There's one? Ah, please.
Just to continue on the Vienna case, I think you said that landfilling was abandoned, and we would like also to promote this kind of solutions in developing countries. Can you give us, if you have, about the costs of collection of municipal waste? Putting bins in the buildings, etc., what does it cost and how it works in Vienna?
In Vienna, we have a waste fee. So every landlord has to pay for each time the waste is collected, each time the bin is emptied. And this is around €4. And you can say basically that every residual waste bin is being emptied at least once a week. And this is how the whole system is being financed. And for the landfill, that no untreated waste is going to landfill, this is because of a law which was implemented in 2008.
I think financial aspects are very important, and our system is a similar one. But to make sure, it differs from city to city. I have the impression that a system which is financed by one fee, not differentiating too much, is the most simple one, which gives very low overhead cost. And that's what we do, very similar to the Viennese system. The landlords pay for each household. Roughly the number for each household, it depends a bit on the dimension of the bins, is roughly between 300 and 400 euro per year. And with that, everything is covered. Also the separate collection of certain items, etc. And this is, I think, roughly a number which is valid all over Europe, more or less.
Thank you very much. I would like to just very briefly continue on the discussion of income, because we talked, of course, about now about fees, income through fees of collection. But since energy is produced and then utilized for thermal or process or electricity generation, there should be income from that side as well. Is the savings, if I look at a cement kiln, for example, as compared to the normal fuel used, are the savings substantial? Are they neglectable? Are the business models similar no matter what you're burning? Or could you elaborate a little bit on the differentiation? I don't know, maybe I start with David and then I come to you. Is that okay?
That is a question that the cement industry is asked quite a lot, and the cement industry, people assume, oh, you guys were spending millions on coal and now you're getting money for waste, you must be making huge amounts of money. But you forget that the cement industry produces a commodity product. It's very, very competitive industry. So what happened with the cement industry is, yes, it had costs associated with purchasing coal, which then reduced. But because it's so competitive, the cement price came down. So what actually happened was that the economic model for producing cement in Northern Europe changed. That you now could no longer afford to make cement using 100% coal, that you just couldn't compete with your competitors. And that's what happened. So I'm answering your question in a sort of a roundabout way, but it is what happened was the economic model for cement production changed as cement companies in Europe started burning waste.
Since we talk a lot about circular economy, I don't mind you using a circular answer, of course. And but that means, in a nutshell, that if the whole economic model changed because of waste, that means in reality the savings, even if it had to be passed on to the buyer of the cement, but the savings must have made a difference. I don't want to say been huge, but in the economic model of running the cement kiln, the overall changes must have had an effect.
Yes, they did. They did. Absolutely, yes. But if I could bring you back to the fact that Ireland was particularly bad at managing its waste, and it was bad because it wasn't taking the environmental costs and putting it into the cost of waste management. So what happened was that cost went back to the polluter, which is the waste producer, and then the cement industry put savings into the customer, and that's how it all happened.
Thank you very much.
Okay, I think that I can give you some detail and how do we understanding the fuel saving for this co-processing. Actually, not all the waste can have such effects for the fuel saving. Let's say that waste co-processing in the typical conception in Western world is using waste to produce the waste into the format as a kind of fuel or raw material, which can be accepted by the cement production. So that is a typical concept. But in China, we're also using this high thermal process to destruct them, So that means just even they don't have some few value of the raw material value. We just purpose to distract them. So for this regard, they don't have any, you see, for this value. So let's come back to what kind of the waste have the value as fuel. Now in China, the municipal solid waste, after it was pre-treated into format of the RDF, refusal derived fuel, it can be accepted by the cement plants. For this regard, of course, the heat value is relatively very low compared with the coal. So that's have a kind of the business between with the pretreatment plant and cement plant. Normally, 2.5 tons of the RDF equivalent with 1 ton of coal. So cement plant need to pay, but it's much cheaper than the standard coal. So from this regard, the cement plant have benefit, and they have incentive to use them.
Thank you very much. More questions from the audience at the moment. I have anticipated actually your hand. So here we go. Yes.
Thank you. So a question for Mr. Peng. China is currently, we know, a hub of innovation and economic development. That's no doubt about that. And China is investing a lot in many countries in the world, also in developing African countries. And I think with these investments comes also an environmental responsibility, in my opinion. So I was wondering, how is China ensuring that environmentally sustainable processes of waste management are also exported abroad in countries which are now on a learning curve, on technological learning curve, and don't have so much experience and nor financial resources to make sure their countries are able to fulfill sustainability targets. Thank you.
I think it's a little bit hard, according to my personal experiences, to answer these questions. You see that now currently the lots of Chinese companies go to abroad to carry out investment. And let's come back to the waste and the environmental or some service business. I don't have much knowledge information for this regard, but some other, some commercial investment that should be very popular. You see, everywhere the Chinese company do that. But as South-South cooperation, because I come from the MAP, Ministry of Environmental Protection, we have the policy to promote the environmental, let's say, environmental impact analysis for all the investment, for all some new plant construction. They need to follow with a strict environmental risk assessment. So I don't know if what explanation is can match with your questions.
Sorry. Let's say we start here and then we move over to you. You asked for the floor? Yes, go ahead. Okay, well, fair enough. Here we go.
Microphone, please.
我来自中国北京的一家民营科
I'm
技企业。
from a private
我
technology firm
的
in
观点
Beijing.
是要依靠
I
创新
believe
来解
we
决今
should
天我们
use
所讨论的问
innovation
题。
to solve the problems we are discussing now.
在此呢，我与大家分享一下我们
Here, I
公
would
司
like to
参
share
与
with you
中国海边城市建设的一些
What my
经验。
company has been doing in the urban development along
大家请
the
看。
seaside, the coastal area.
这是
Please take a look.
一块砖，但不
This
是
is a piece of
普通的
brick,
砖。
but this is not an ordinary brick.
吐水的。它的面层是用沙漠上的沙子为原料，产生沙尘暴、沙源的
we
沙子为
use
原
the
料
sand
表层。
to make the surface of this brick. Underlying that layer, we use the tile waste and construction waste to make this kind of bricks. We spent 7 years in doing the R&D, and we have got a lot of
到了
patents.
土壤这专一后，完全
After
消
we
除
laid
城市内
down the bricks on the city roads, we can prevent the flooding in cities.
大家再看，
Now, please take another look at this.
这是个花盆，
This is a flower pot.
大家看好，
Please look carefully.
它具有透气不透水的功能。 它
Water
的作用
cannot
就是
go
把我们收
through.
集的雨水在储存的时候，
This kind of
能够
pot
使它能够长期保鲜，并且
Can
使
save
水
the
能够净
rainwater
化。
for a long time and
用
also
它来
can
把
purify
雨水
the
收集同时
water.
能够解决
We can use this
天
to
气
collect
雨水包括脏的
rainwater.
雨水、污水净化的问题。同时，它能够把
And also
把我们的
this
河道里
Pot
水变清、
can
变
make
蓝，
the
是吧？
river
就这
water
两个技术结合起来以
clean.
后，完
If
全
we
为我们城
combine
市的
these
生态
two
环境提供
technologies
长远的
together,
科技
then
支撑。
we can
我们国
provide the
家
strong
现在30个
technological
海水
support
中
for cities.
都在用我们这项技术，
More than 30 cities, more than 30 coastal cities are using this technology.
因为时间关系，我不能多
Because
说
of。the time, I cannot
欢迎各
go
位呢
into much more
到中
detail.
国、到
So
北京、到我们公司去
I would like
考察、去
to
看我们
welcome
这
all
些
of
项
you
目。
to China
谢谢大家。
to pay a visit to my company. Thank you.
Thank you for the fascinating example. It of course deals with something a little bit off the main topic here, but nevertheless a very fascinating demonstration actually. Thank you very much. And well, we'll see where we go with that. Good. Any more questions from the broad audience here? I know you still have one left, don't worry. Yes, please.
Thank you. It's in line, it's from Mr. Tobin, in line with the same topic you brought before. It was my question. It's clear that cement producer produce cement. This is clear, and that you are using waste, reducing your amount of coal. My question is more when you, instead of having, let's say, energy sources, let's say waste, you have waste which is not producing energy, any energy. Instead of this, it's putting problems. Let's say if you are reprocessing any refrigerant with a chlorine or fluorine, how to sell it to the cement producer to reprocess this kind of things or materials. Thank you.
Okay, chloride is the enemy of cement production, and what chlorine does, everyone thinks of chlorine and thinks of dioxins, but in cement chemistry it's different. What happens is that when chlorine enters the system in the kiln as part of the waste, it travels up through the cement plant until it gets to a cold area. And it starts forming HCl, hydrochloric acid. And if you think about cement production, it's all about lime, it's calcium carbonate. So you have an acid going one direction, and then you have 1 million tons of scrubbing of calcium carbonate coming against it. So it's a very effective scrubber. So you have a chlorine cycle. So what you form then in the kiln is calcium chloride, and your calcium chloride goes back down to the high temperatures, and then you have chlorine gas, and then you have HCl, and this cycle keeps going until it finds somewhere cooler in the system, and it starts plating the inside, and you get a build-up, and you can have a 6-meter duct inside in a cement kiln suddenly becomes 2 centimeters because it just piles up. So the cement industry then has to go out and chisel this out, and it causes huge problems and breakdowns, and cement production people get very upset about it. And I get into trouble because it's my fault, and this never happened before until alternative fuels came. But of course, these things happen, breakdowns happen. So the cement industry does not want chlorine and would be very careful to screen out chloride material. And I say chlorine, PVC with its organic chlorine, or food waste with sodium chloride salt. We don't want either of them. So there's a lot of pre-processing, and there has been a lot of research and development and a lot of monitoring. And every fuel delivery we get, and we get a truckload every 2 hours, 24 hours a day for 330 days a year, but every single truck is tested. And we are looking for chloride, we're looking for mercury, we're looking for water content and calorific value. So we're much more evolved from a waste into thinking about a fuel. So your waste processor becomes a refiner for all intents. So the challenge for the cement industry is to keep going at 100% production while using as much alternative fuel as possible and while not breaking the plant, and that's the challenge.
Correct. Yes. So I fully agree with the Mr. David, and I think that your question about chlorine and other mercury is damaging elements. I think now regarding with the chlorine control, the input is very important. Even it has entering this system, we still have some technical solution for these problems, such as the bypass. But you see that I fully agree with David's mention. That's quite a key. The problems we need to alert for waste co-processing. But these problems is already settled. I just want to strengthen about that.
And this forms a really excellent, and I'm sorry for question number 4, good. But you might address it afterwards on a bilateral. This forms an actually excellent closing remark for this session, because essentially the conclusion I get the discussion moved to and finished with was to have a different look at waste from starting being a problem that fills up landfills, over being more and more of a fuel which can also generate electricity and heat, to become really a fuel resource, and to become more because you have only one fraction going into that fuel resource and others into other uses, recycling, circular economy. This, I think, will be a very interesting direction to move forward and to bring the know-how that you have said is existent in processing the fuel to make it fully acceptable for the kilns, is existing, but of course not that widespread, and to consider where the economic models that we also discussed today favor that waste is being used as a safe alternative fuel for cement kilns, which are probably the most widespread single industrial application where heat is needed in large quantities, continuously needed globally, and because of transport issues, typically not far from major cities. And this is something that maybe we can all take home and think about whether there are opportunities and how to possibly further that issue. And I would like to thank all of you, but in particular my panel and you as the keynote speaker, for their presence here and for your interest in the session. I'm very happy. The 10 o'clock in the morning session is not necessarily the best spot to start, because not always everyone comes up with a lot of interest at 10 o'clock in the morning, but I see all of you did. Thank you very much for being here. Thank you very much for your questions. And I hope you have an interesting day today, interesting discussions. And I hope we will continue what we have started today in different fora in the future and move it forward. Thank you very much.